Hey kids, Smath here. Here we go in our third video on chapter 18, reaction mechanisms. Now in this video, we're going to talk about the pathway that certain substances take where they proceed from reactants to products. So that pathway is called the reaction mechanism, right? Now these mechanisms are pretty straightforward for us to understand. There are single-step reactions that are called elementary reactions. These elementary reactions are usually going to be given to us, and from those, we can determine the reaction order and the reaction, the rate law from these. This is where reactants are converted into products in one individual step, super simple. Unfortunately, most chemical reactions out there in the real world, they involve complex reactions. These are going to have more than one step. Each individual step is called an elementary step. And so in the pharmaceutical world where we're making an antibiotic, that reaction mechanism may have 4 or 5 different steps, elementary reactions to it. All of the elementary reactions in a complex added together make up what's called the reaction mechanism. Now, during this, they produce things that are called intermediates. Intermediates are real simple. We're going to define those for you right here. These are produced in one step and consumed in the next. And we're going to look at these graphs a lot more than we're going to look at reaction mechanisms. So mechanisms, there's such a thing called activation energy, and that's going to determine K. Here's the good news. We're not going to worry about this law at all. We're going to worry about activation energy. K is the same K we just dealt with when we did the rate law. K is going to determine how fast it is. Here's what you need to know about mechanisms. Mechanisms show up as graphs. And on this graph, it says, hey, would you mind labeling some stuff for me? Show me where the reactants are. Show me where the products are. Well, that'd be a whole lot easier to do if we had some axes on this graph. So why don't we do this and grab that. And let's put some axes on this. Whoops. Okay, I can't do that. I got to clean that up, kids. I'm sorry. There we go. On the x-axis, that's going to be time. Another word for time would be progress, reaction progress. And on the y-axis, simply put, is going to be energy. So, label the reactant, the products, the intermediate, and the activated complex. So the reactants are going to occur on the left-hand side where we're at time 0. The products are going to occur when this reaction is over. The products are going to go there. Intermediates live in the valleys. Simply put, they're intermediates. What happened was we have a reaction that occurred here in this first hump. And there was a reaction here, and this reaction formed this intermediate. That intermediate went through a second reaction and formed a different intermediate. That intermediate went through a third reaction and eventually formed a product. Okay? So reactants form intermediates. Intermediates end up forming the products. Intermediates live in the valleys. Well, what lives at the peak? That's where the activated complex lives. Remember when we defined that in the very first video of this, that activated complex is a very high energy, short-lived, boom, out of the way kind of thing. So that's where the activated complex lives. Now let's look at these. So we've labeled reactants, products, intermediates, and activated complexes. Now let's label the two questions down at the bottom. How many steps does this mechanism describe? Well, 1 step, 2 step, 3 step. Plain and simple. This reaction involves 3 steps. So we would have three elementary reactions given to us. And then it says, which step is the rate determining step? That's going to be step 2. How come? The rate determining step is always going to be the one with the highest peak. Plain and simple. So the higher the peak, the activated complex gets formed. As soon as the activated complex is formed, this reaction is going to proceed as written to products. It's kind of like the halfway point of where it can go from reactants to products. Now, let's look at another one that's a little cleaned up. Here's a good example. Okay. We have intermediates that are living down in the valleys. Intermediate, intermediate, intermediate. How many steps? This one should have, and this reaction coordinate does not show this very well. This should have 1 step, 2 steps, 3 steps, 4 steps. Now they only showed us the first 2 steps that these are given, and here's why. We know that this first step is going to be a fast step, and this second step is going to be a slow step. Okay? Other than that, the mechanisms themselves, we're not going to get into, we're not going to figure out. All we're going to do is interpret the graphs. And so in this case, the second step has the highest peak. That's where the activated complex was formed. And that's what's going to control how fast this reaction is going to occur. I'm Smath. This video is reaction mechanisms. I hope it helped.